I amperes flow through a resistance of R ohms varies according to the probability distribution. You are given two probability distribution. You're giving f of I to be that, and you're giving g of R to be that. And the question is, find the probability distribution for power, W. But that very W, please take note of this. W here is a function of I and R, and the distribution for I is giving, distribution of for R is giving. You know what I'm going to do? I want to go from two variables to one. Then I need an artificial variable. Does that make sense? That I can carry. But that very artificial variable is going to be a function of any of these. Like here now, I can actually, since W equal I square R, I can introduce a new variable, maybe V equal one of these, okay? But I can say equal to R. I can say equal to R or equal to R, because this is going to be integrated out at the end of the day. It's just helping us so that we're going to move from 2 to 2. Now, right now, you were told that, when you take a look at this, you're told that they talk about independent, okay, which means I and R are independent. If I and R are independent, I'm actually going to have f of IR will be equal to this multiplied by this. If they say they are independent, our four of us get that. So I'm going to multiply the two together. I'm going to multiply these two together. That will be 12 IR, 12. I'm actually going to have 12 IR into what? 12 IR into 1 minus I, right? 1 minus I. Okay, four of us get this. Then I will come here to find the inverses. Here, R equal to V. Okay, now you're actually going to see R equal to V. Then here, I need to solve for I. Okay, I squared equal W. Okay, I squared equal W over R. But what is my R? R is V. Right? And this implies I squared equals square root of W over V. Okay? Oh, sorry. I equal that. And if you take a look at this, these two are my inverses. Okay? Then I need Jacobian. But the Jacobian is going to be a matrix because I got two variables. The other time, when I was only focusing on this in this question, where we have one-to-one, the Jacobian is not going to be a matrix. But right now, I'm actually going to, I'm going to do the R, the V, the R, the W. Then I'm going to come here, the I, the V, the I, the W. Okay? So when you set up your inverses, we're going to differentiate the inverses with respect to, here, V. We're also going to do with respect to W. Then we'll do the same here. Now, the moment you are done with your Jacobian, you know what you're going to do? You want to get f of W, or f of WV first. F of WV. Now, to get f of WV, okay, here, wherever you see I, you're going to put this guy. Wherever you see R, you're going to put V. The new distribution now is going to be a function of W and V, then multiply by the Jacobian. Does that make sense? That is what you're going to do. I will leave this on purpose, and I'll go to some other examples. I'm leaving that on purpose. Now I need it to be focused right now. Let me look at my time. This is 9:26. Now be focused right now. Now, do you know that if we have, for instance, a gamma distribution, do you know that from gamma we can derive beta distribution? In this class, we've done gamma, right? We've also done beta, but we can derive beta distribution from gamma. Please, I need you to pay attention. Now, you know, when x follow gamma with parameter alpha beta, we have f of x equal this. Right? We have this. Now, what I want to do now, if beta equal to 1, okay, we're actually going to have right? This is also a gamma distribution, but a gamma distribution of one parameter. This is a gamma distribution of two parameters. Now, you know what I want to do now? If x1, okay, follows gamma with parameter alpha 1, and x2 follow gamma with parameter alpha 2, okay, where x1 and x2 are independent, where x1 and x2 are independent, okay, obtain the distribution of y1 equal x1 over x1 plus x2. Please, I need you to pay attention. Okay, you know what I want to derive? This is what we're going to do. We want to derive, this is derivation of beta distribution. You know, you saw that we were using beta distribution the other time. It was derived. How do we derive it? And I needed to pay attention. Okay, I told you, this is a one parameter gamma. Now, if x1 follow a one parameter gamma with parameter alpha 1, and s2 follow s2 is also a gamma variate with parameter alpha 2, and x1 and s2 are independent, okay, obtain the distribution of y1 equal to this. You know, at the end of the day, you know what we're going to get? If you obtain the distribution for y1 will be a beta distribution. Okay, why? This is looking like a probability, right? x1, s1 is also part of this. That's like a probability, right? Now, I need, you know what I need you now to do? I need you to focus on the board. If you don't understand, you ask question. Now, I want to start the proof. Okay, now, right now, we are given here y1 equal x1 over x1 plus x2. But we cannot go from two variables to one variable. Therefore, I need to introduce an artificial variable. So I'm going to say y2. Now, whenever you have a fraction like this, and you want to introduce an artificial variable, you use the denominator, okay, which is this. The denominator is the total. Now, you know what I've done? I've created an artificial variable that I'm going to integrate out later. Now, I need to find the inverses. Okay, find inverses. Okay, now if I want to find the inverses, I can start from here. Please look up x1. x1 equal y1. What is this? y2. Any question? I found the inverses for x1. Then I'm going to come here. What is my y2 equal? My y2, what is x1? y1, y2 plus, what is x2? Let me see. Oh, sorry. I'm finding x2, sorry. Now, I want to find this guy. x2 equal y2 minus, what is x1? y1, y2. Is there anyone who doesn't understand how I find my inverses? Okay, you solve for x1 and x2 in terms of the new variables you actually go into. Okay, now the moment you're done with that, the next thing you actually are going to do okay, so the next thing you're going to do is, because we are told that x1 and x2 are independent, you get the joint for the old variable, of course, which is going to be this multiplied by that, because you say x1 and x2 are independent. Now, when x1 follow gamma, okay, now x1 follow gamma with parameter alpha 1, f of x1, of course, is going to be this guy. So x1 alpha 1 minus 1 exponential raised to power this gamma alpha 1. Then f of x2 is going to be this. You see that? Now I want to multiply them because they are independent. Okay, so f of x1, x2. So multiplying them, I'm going to have this. Any question on that? Multiplying them, I get a joint, right? Now, after getting this joint, you know what I'm looking for? I first want to get f of y1, y2, which is going to be the joint of the new variables I'm going into. And if I want to get that, I'll first need to do x1 in terms of y1, y2, x2 in terms of y1, y2, multiplied by determinant of Jacobian. That's how I'm going to get that. Now, it's trying to say here, wherever I see x1, I should put this. Wherever I see x2, I should put this. I'm multiplying by the Jacobian matrix. Now, if I want to set up my Jacobian matrix, I'm actually going to come here, the x1, so it's going to be the x1, the y1, the x1, the y2, the x2, the y1, the s2, the y2. Now, right now, okay, what is the x1, the y1? The x1, the y1 is y2. Y2, what is the x1, the y2? Y1, right? The x2, the y1. The x2, the y1, that is negative y2. Negative y2, then the x2, the y2. The x2, the y2, that will be 1 minus y1, right? 1 minus y1. Okay? Is there anyone who doesn't understand how I set up my Jacobian matrix? Is there anyone? I differentiated this guy here and this guy here. And that may look like a partial derivative. Yeah, go ahead.
So you differentiate with respect to x1, y1 both?
Yeah. Look at that. The x1, the y1. The x1, the y2. The x2, the y1. The x2, the y2. Each of these are different.
Okay.
But you have to maintain. If you want to do x1, x1. x2, x2. It has to be different